Okay, so this is one of the shots I liked the most. Look at the amount of houses we do have, and I mean, for the amount of houses we have, this is actually very, very efficient to look at, believe it or not. No, this is incredible. And the camera looks something like this. So let me just open this and show you in media what we're talking about. So this is a test render. As you can see, it does look incredible, even if it's on a slow frame rate. So there are a bunch of tricks going on. This is one of the best organizations we did, I believe. So let's begin with the basics. So to begin with, we imported the camera. Later, we did everything that has to do with environment. The environment, remember guys, is the same trick of getting the houses. And in this case, I sent it through a primitive because I wasn't able to get what I wanted in terms of creating the structure. And then I put everything inside this scene, the same for this one, because I wanted to separate this in the foreground and the background. Then everything on a collection, and later on I had these prunes, and these are all the houses I have. Amazing. So how are these scatters done? Well, it's just a little clever way of doing the points. If I go into the external sub of the points, which is this one, you will see there's a bunch of things going on, but it's actually more of the same. So let's begin firstly turning these effects off, so it's easier for me to actually look at this. Let's go into the type, no, not into the Titan, but into the scatter. And where we have the grid, this is the place we're getting the camera. So not the final bake, I believe. Oh, I'm generating some houses. I don't want to generate some houses. So as you can see, we animated the camera, and the camera is animated with an extract geo, which I'm going to explain later on. So this scatter was done with a grid with some UVs for the textures, with some subdivides, and then there was a sculpt. In this case, there wasn't anything particular to it because I ended up doing it with some noises for this sculpt real. As you can see, this is where I'm going to be setting all the houses. It's just a random noise of the position, another noise. There is just nothing crazy about it. I'm rotating this grid in order for me to have a better, in order for me to orient the houses a little bit better. Then with the did node, I just changed some points which are near the camera a little bit. Let me look for them if I can see them. I think, yeah, this point was too high and I lowered it. Then I subdivided this a little bit more and have well, I have the sculpt real. On this grid, I scatter a bunch of points. I grouped some of them. This is what basically this is where the Titan is going to be running to. But remember, this is rotated, right? So I'm going to be rotating it on the same axis. So this is the same. This should, in fact, should be like this. So it's actually always being referenced. Here I'm adding a little, some variance. Remember, if you have a random number from the point number and multiply by 6 and floor, it should be a 0 to 5 integer number. Then with an expression, I'm creating an orient attribute. I'm setting the scales. Basically, some of them are higher. This is the same trick we did for previous shots. And then I'm randomizing the orient. And then I'm just blasting everything that's not in this group. Basically, this group is made with the following way. This is very clever, guys, so keep note. I'm having this frustrum and I'm trailing them to the final frame, 33 frames. Then I'm doing a BDB and I'm grouping everything that's inside here and I'm blasting. So I'm just going to get the houses that I actually need, nothing else. Then I'm merging these two guys together. One of them are these lines with some variance again, a scale and a randomize and a translate. This is going to be the foreground houses. Remember, these are just points. This is going to be grouping for whatever I want this to be the front. And I'm going to edit a couple of points here and there so it's a little bit better. And I'm going to just have the houses and copy them all over the place. So like this, you can start moving the houses to your liking. Let's say you want to select a couple of points here. You could just move them. And these, remember, are all instant. So it's actually extremely fast to do so. And you will get exactly the same result in stage. So look at this. This is quite awesome. So this is one part of the scatter, which are the houses. On another side, we are also doing the same, exactly the same thing with less points for oh, this is also an attribute for the randomization of the colors of the houses. But in this case, we're doing exactly the same thing for the trees. See, it's exactly the same thing for the trees. The same trick, there's nothing different, but instead just less variance. Finally, well, not finally, but we also have the tower, which is exactly the same thing, scattering points. This and this is exactly the same, scattering points, scattering randomization of variance, and getting the points we wanted, and on top of this just scattering some buildings. In this case, the variant is overriding my points because I only have one variant, so this one could be reduced and we would having more, but in this case this was done so it can have a little bit more correction, right? And I added a singular point, which is this one, so I can change the points where I want it to be. So this is, everything is scattered, but this one is hand placed. So what I'm doing here is that I'm getting these points and I'm adding everything, basically just removing the lines, and I'm making a randomization for the color of the houses. I'm splitting the houses on the back, the front. I also have some points which I'm going to be using for the smokes. What I'm doing here is just removing most of them and scaling the scale by 3 because the smoke has to be big. And this is for the trees. This is for the trees. But I think I ended up using this one. Well, one of these is being used for the trees, and I believe it is one because it has the reference right here. So this is all the scatter workflow. And for the Titan, look at this. I created I have the Titan. I blasted a part of the Titan. This is not the part that I chose. In the original setup, I just selected this and blasted out. I created a box and then I sent this to Chops. And in Chops, I grabbed the node. I set this to animated, the position, and I filtered this. What this is going to be doing is that once this comes out, it's going to be affected with a delay. It's going to have like a delay action. It's going to be also soft into the animation, right? So this point is going to be what I'm going to be using for me following the camera, or at least having like an original following up action. This is also, I need to have the static shape in order for me to have both the centroid, both the static and both the animation. And then I'm going to extract the centroid. What I'm also doing, if I'm not mistaken, okay, this should have been the eyes of the Titan. I believe we changed the Titan in the meantime. So this is going to be used for the eyes, for the lights coming from the eyes. Once we have this, with extract camera, this is the cam final. I am actually using the static and the animation to edit this, and I'm making the necessary keyframes for me to actually look at what I want. Then I just bake this so I can have everything baked into position. So we have everything we need, the effects, whatever. So if we dive into here, we're just using the points, the houses. So this is exactly the same setup, but with um, Solaris. So you will see there is a house, an extra house, which was basically clipped into here. So when the camera follows through, it just works. I decided to do it hand placed because I wanted to be precise of what I needed. I added the materials and I did the same for the trees and I did the same for the towers and I merged it with the sculpt of the ground, and this is overall all I needed. Now with the camera, this looks something like this. So as you can see, I have the foreground elements plus the background elements, and it's looking quite nice. Then I'm also scattering with the same trick some smokes. This is a good thing about Solaris, that you can just copy and paste everything as long as you have it into a collection. You can just call the collection and then do a random selection and add a material to them. And finally, well, this is for the effects of the grains. They are turned off at the moment, but they basically look like this if I add them into the pipeline. See, they are following the action quite nicely. Then we're adding the Titan, we're adding the eyes, and this is important because, okay, this is the hair too. We're adding the eyes, and we're setting this to render no primary, so it's only secondary. The LP type is going to be eyes, and you are going to be treated as a light source. Then we're going to be adding an emission material. And for the LP to be shown on the lights, we should have one of these called eyes. Let me just look for it. Fill, HDRI, sunlight. It has to be somewhere. Okay, we didn't add it, so we didn't have the LPE. So what we did is to do the difference from all the render passes. So it is not ideal, but it worked because it was the only thing that we didn't kept apart. But you should have added a new light with the base property set to 0 and the LPE tag named after this guy right here, the eyes. What's this? This is the smoke from the nose. So everything is materialized as usual with the wall. The wall is going to be like around again against the overall objects, and it's going to be also transformed, so it's a little bit higher, so it's more similar to the actual reference. And overall we have this. Well, the lights is a simple HDRI with some lights which are being copied to point. This is why we have the points which was got from the actual transformation of the cube we did before. The instant base name is light underscore, so we're going to be having fill 1 and fill 2, and with this as a prefix. And the light mixer is going to be what we're going to be using to edit the lights. But as you can see, these lights are in fact moving and following the Titan animation. You see, they are following the Titan in some shape or another, and the Titan is actually running in the ground, but nobody actually knows. So it doesn't really matter as long as it looks nice on the camera. And then we have distant light, and we are linking some stuff. For example, the distant light is not affecting these guys, and the light 1 and light 2 is not affect. It's just affecting the character. So what's going on here? There's a singular node motion blur, which is actually going to account for the camera motion blur. So let's go into the Titan, or let's in fact go, yeah, let's go into what's going to be the midground, which is this one, and this one should be the Titan. This will take a while because it's going to load all the frames from between each other. See, now it's calculating the subframes. And once we have this, we could set this to karma. And if we add the materials, because we didn't have the materials, it should be initializing with the materials. Now that's different, right? So we have the fill light of the back, another fill light on the front, from the smokes, from the HDRI, from the crypto material, the crypto object, and some others. In this case, we chose to have everything in a single layer. So what happens with the foreground? Let's go to the frame 1008. Let's cancel this one if we can. Let's go to this. Remember, we are calculating with the motion blur node. And one thing to keep in mind is that all the trail nodes which are calculating the velocity blur are in acceleration mode. So they are also calculating the acceleration of the formation blurs. So if I look from the camera and I start rendering, you will see this. This is one of the houses. Let me just turn the background off. So this is one of the houses, and it doesn't have motion blur. It has camera blur. In this case, there is no velocity blur because we don't have any velocity. But if we were to have, it would account for both things: the motion blur of the movement and the movement of the camera. Otherwise, this would have been quite a challenge without motion vectors.